Okay guys, here comes our second part of our example sheet, sheet number 2. This problem reads to what temperature must 500 grams of brass cube be heated to convert 60 grams of ice at temperature of minus 20 degrees Celsius to water at 30 degrees Celsius. We need to figure out how much heat's required first of all, so we're going to grab our handy dandy Q equals MCAT equation again. Let me see if I can just insert it real quick. Here it comes. There it is. Notice it's much shorter than last time because the only thing we're trying to do now is convert 60 grams of ice at negative 20 to ice at 0 degrees. Then we got to convert that ice to water at 0 degrees, and then we just got to heat it up to 30 degrees Celsius. That's why you have such only three components. Our next step is to come in and let's get over some numbers going. We notice again that all we have to do is, instead of me writing it this time, I'm just going to make everything nice and pretty. Here we go. Here comes the Q. Q equals 0 degrees. We're heating it up. We need a specific heat of ice. Take it from to negative 20 to 0, becomes plus, so that's positive energy. Then we're going to convert that guy over to water at 0 degrees, and then we're going to heat that water up to 30 degrees Celsius. So looking good so far. That calculation gives me a nice number of, let's get a text box again real quick. Ooh, didn't want that. So let's go back and grab this piece. That's what I needed because that's my final answer. So now we know how much heat we need. Who's supplying that heat? A 50-gram brass cube. So we need to figure out how much heat, what's the temperature we got to heat this guy up to get that much heat. So we're going to go back to Q equals MCAT again. I'm going to go ahead and get the whole calculation and be done with it. Then I step you through the calculation. How about that? Sounds like a winner to me. Cooking with grease. Let's go ahead and paste this guy down, see what we're looking at. Okay. That's just part of what I want. Let's see if I can get the rest of it real quick. Nope, it's not letting me copy it. See if I can copy it from here. That's okay, I can just write that, no big deal. Let's go ahead and take this over here. We know we're trying to grab that again real quick. Get a text box. There we go. Notice how I rearranged everything. We know we got Q equals MC delta T. We know delta T is final temperature minus initial temperature. Isolating the TF, I switch these around. So that should give me, I'm missing a Q right here. So let's clean this up real quick. Let me just take my pen and show you what I'm trying to do. I know this guy right here. We're going to scratch that out, scratch this out. If I divide both sides by MC, I end up with TF minus TI. If I bring that TF to this side, I get TF is equal to minus QMC minus TI. You know I don't like negative stuff, so we're going to change that first one to be positive. Q over MC plus TI. Now the trick becomes, you got to remember, you're trying to find that final temperature. I'm going to assume that since my previous calculation gave me right here, right? That guy gave me 30,072 joules. My mass was 0.05 since it was 500 grams, and that's wrong because it should be zero point 0.5, right? 1, 2, 3, 4, 0.5, 60 grams of ice. Yeah, the brine should be 0.5 grams. So let's go back and erase this guy right here. Grab the eraser. That should be 0.5 grams. So now that's telling me I should have 0.5 grams times my specific heat of brass, which is 377. And then we added 20 degrees because we're going to assume that this guy is sitting in room temperature right here. So now after you do all that math, you should end up with the final temperature of 179.533 degrees Celsius. Somebody check my math. That should do it. Thank you very much. Remember, do it in pieces. We went from ice at -20. We had to bring that to ice at 0 degrees. We had to make that ice into water at 0 degrees. Then we had to heat that water up to water at 30 degrees. So that should be 1, 2, 3. Sounds like a winner. Thanks.